Good morning, kids. Welcome to practice test day 7. So I'm a little sick, maybe coughing. It's going to sound like crap in that microphone. I apologize. May have to take some breaks. May have to drink me some more Brugger's coffee. Might have to actually go to tea, but right now we're going to stick with this and see how we do. So let's get started. This is going to be a very long video. Not really sure exactly how much of this I'm actually going to assign, but for those of you who want a lot of practice, here's a lot of practice. So, we're going to quickly go through this. So hopefully you get it. So, first thing we do when we condense is return logarithm. So we need an m squared. How many of them have m squared? This doesn't have an m squared. This doesn't have an m squared. And addition goes back to multiplication. Done. First thing you do is return the exponent. How many of them all have an x squared? Nope. Nope. How many of them have a y cubed? Just those two. And subtraction condenses to division. All right, return the exponent. X squared. Doesn't have an x squared, doesn't have an x squared. Return the 3. Y cubed. Doesn't have a y cubed, doesn't have a y cubed. Okay, so this thing is the thing that's on top, and we're subtracting these. These things are going to get multiplied, but since they're on after a subtraction symbol, they're actually going to be on the bottom. So the y cubed and the z are going to be both on the bottom, which is why it's choice 1. So here we go. We got log 10. So what we have here is division. So we got log of 10 to the x plus 2 over 10 to the x. Well, when the bases are the same, what do you do with the exponents? You subtract them. So you really have log base 10 of 10 squared, or 100. And if you can just type that in your calculator if you want to, it's just 2. Choice 2. All right, let's return these exponents. A half as an exponent is a square root. So how many of those have a square root of m? So we're down to those. Return this 3. Who's got an n cubed? N cubed, n cubed. Subtraction goes to division. All right, that's them. First 8 are done. 92 to go, or what the heck it is. All right, so this is a 1/3, so we need a cube root of a. Nope. All right, so it's going to be one of those. And then, oops, got to return the 3, so who's got a b cubed? Doesn't have a b cubed. And then this goes to division, so the b cubed will be in the denominator. Return the 3, we need an x cubed. Return the 1/2, we need a square root of y, but this one doesn't have an x cubed. And this one doesn't have a square root of y. Done. Return the 1/2, we need a square root of a. And a b squared. Doesn't have a b squared, doesn't have a square root of a. So it's one of these two. This condenses to division, so it's choice 1. Sorry. It's going to be a long video with my voice. Return the 1/3. That's a cube root. How many of them have a cube root of m? Just these two. Return the 2. How many of them have an n squared? These two. Subtraction condenses to division. Page 1, done. Now we're on to page 2. So, without a calculator, don't forget what you're going to do is you're going to say, just to do these without a calculator, you say, okay, this is equal to x. All right. So, if it's equal to x, then what I say is, it's logarithm. I want to change its form. So I say, okay, it's all about the base. 8, and then these two switch. 8 to the x is equal to 64. So what exponent do I need? I need a 2. Same thing here. Log base, well, I don't even need this. We're just going to set this equal to x, right? So it's all about the base. So 5 to the x equals 1 over 25. Well, first of all, what kind of an exponent makes a fraction? Negative. Okay. What number gives me so I can have 25? 5 squared. So negative 2. All right, so change of base. 9, why did I do that? 9 to the x equals 81, so x equals 2. This problem's a lot different than the one before. We'll just call that 2 and be done. That's weird. All right, so here we go again. So 100 to the n equals 10,000. And 100 squared, so n equals 2. And if you square it, you get 4 zeros. 4 zeros. What value k will the graph blah, 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 blah contain the point 1 something? All right, so you need to understand and remember that all logarithm functions go through the point 1, 0. Or when you take the log of 10 to the 1, and you say, okay, that's got to equal some value. We'll call it v. 10 to the value equals 1. Well, what exponent do I have to raise things by to get 1? 0. Or you can remember it goes through 0, or you can just try it. I should have probably had my calculator up, so that was a mistake. Sorry. So I'm just going to type this in now. Because this has got nothing here, it's a base 10. So I'll use this opportunity while my calculator loads to take a pause and talk about roasted coffee nuts that taste good when ground up and thrown in hot water, sort of. Okay, I don't feel like my calculator's getting... There it is. So, by the way, I don't need this. I don't need this. So log of 742.6. So go to the calculator. And go log. Now, since it's base 10, I don't really need that. Oops. Since it's base 10, I really don't need that. I'll just get rid of it. 742.6. Was that right? Did I remember that correctly? 742.6. Enter. The answer is 2.87, round to the 10,000s place. 2.87. 075. 07549. So 2.10,000s place. Tens, hundreds, thousands, 10,000s. 2.8708. That was crazy. Alrighty, here we go. Whoa. So, all I gotta do is type this in my calculator. Control log base 2 of 9 equals, what do I round to? Here's 10th. 3.2. It was 3.16, so it's 3.2. Log base 2 of, well, we just got to type it in, really. But log base 2 of 1, you can just do this if you want. Control log base 2 of 1 is 0. That should be obvious. And then I think you'll see in a second log base 2 of, I should just hit the up arrow, of 2 is just going to be 1 because 2 to the 1. And then what would give me here would be squared. What would give me a half would be negative 1, and this would be negative 2. You can use your calculator, or you can just do that. I don't know what I just said. Log base 3 of 5. So these are all just calculator stuff. If you don't have the calculator, I'm going to have you use that in class so you can check your work. Log base 3 of, what is it, 5? Is 1.46. What do I round tens place? So it's 1.464. 1.464. Tens place would be 1.5. Log base 7 of 75. Log base 7 of 75 equals hundreds place. 2.2187. 2.2187 hundreds place. 2.22. Wow. 222. 2222222. Log. These are kind of getting old. Now, since they don't have a base, I don't have to put a base there. And it's 10. You could put a 10 in if you want. 58.43. I think that was what it was. 1.766. 4 decimals. So 1.766. 635. 635. So 1.7666. I feel dirty doing that. I feel like a heathen. Again, 4 decimal points. Just control log. I won't ask you to do all these. 429.7. I think you get the idea. I don't know why I put them all in here. It's kind of silly. 429.7. Especially when I can't even do the own problem myself, right? 429.7. 2633. 2.633. Oh, I'm just rounding it. 2. Done. Log of 1985. All right, I hope this is the last one of these because these are kind of boring. I think you guys get it. 4 decimals. 3.2977, I believe. 6. So the answer is 3.2978. All right. Page 2. Done. Oh my gosh, I got one more. Thought I was done with these. Log of 2001. What the heck? Control log. Why keeps doing that? 2001. Control log 2. All right, that's base 10 of 2001. You'll notice when I do this, I think it gets real. Okay, puts the 10 in. Oh, when I don't put the 10 in, it puts the 10 in for me. 3.301. 3.301. My dog's coming down to say hi. 247. 247. 10,000 place. Tens, hundreds, thousands, 10,000s. So 3.3012. All right, done with that. A scientist in a laboratory company raises amoebas to sell to schools for the use in a biology class. They know that one amoeba divides into 2 amoebas every hour, and that the formula that can be used to determine how many hours T it takes to produce a certain number of amoebas N. Determine to the 10th of an hour how long it takes to produce 10,000 amoebas. It's a lot of work just to go like this. T equals log base 2 of 10,000 amoebas. So control log 2, 1, 1, 2, 3, 10,000. It's going to be a lot. 13.2877. That was a joke, by the way. 2877 to the nearest 10th of an hour. 13.3 hours. All right, so if you remember correctly, you can't take the log. I don't care what the base is. It doesn't matter what the base is. You can't take the log of 0 or anything less than that. So what you got to ask yourself is kind of like a fraction here. What would make this equal to 0? It's kind of like the denominator of a fraction. What would make this equal to 0? And the number that would make this equal to 0 is 4. So if you had anything that's less than 4 or equal to 4, it's going to be 0 or negative, and we don't want that. So less than or equal to 4. All right, so it's undefined for all values less than or equal to 0. 4. When is log x undefined? Again, it's just this can't be 0. So x, it's undefined when x is less than or equal to 0. So let's see, which one of these is less than or equal to 0? Oh, 0. There it is. As long as it's bigger than 0, you can take the log of it. Undefined. So what would make this 0? Well, the value of 8 would make this 0. Now, if I make anything bigger than 8, that would be like 8 minus 9. That would make negative. So we can't have anything bigger than 8. So it's defined for all values less than 8. You can't even be equal to 8 because you can't take the log of 0. So it's less than 8 is when it would be defined. All right, kids. Bases are the same. All you do is set the exponents equal to each other. So x squared plus 2x equals negative 1. X squared plus 2x plus 1 equals 0. X plus 1. X plus 1. So my one and only answer is x equals negative 1. There it is, done. My bases are not the same, and we need to make them the same. First thing we're going to do is put parentheses around these, so we don't do anything dumb. So we get 2 squared, that's the 4, times 2b minus 3, is equal to 2 cubed times 1 minus b. Well, now that the bases are the same, we just set the two exponents equal to each other. So we get 4b minus 6 equals 3 minus 3b, or 7b equals 9, or b equals 9 over 7. Now, that seems like a really dumb answer, right? So let's check it. If I don't feel comfortable about my answer, why wouldn't I check it? I'd check it anyway, because that's just kind of who I am. I like to get the right answers. I like to check things. Why not? Check them. I haven't looked at you guys in the face. It's kind of weird when I'm always looking down, but I'm trying to look at my work. So stop yelling at me. Let's store that into x. And then we're going to do, I should have said b, but whatever. 4 raised to the 2x minus 3. 2x minus 3. Hit enter. Get some weird number. And then 8 raised to the 1 minus x, and you get same dumb number, same dumb answer. Yay! Got to be confident about your work, kids. All right, so 81 and 27. We're going to convert these down to 3. So this would be 3 to the 4th times x plus 2 equals 3 cubed times 5x plus 4. And again, once they're equal, you set the exponents equal to each other. So it's 4x plus 8 equals 15x plus 12. Bring this over, I get 11x equals negative 4. Wow, another dumb answer, right? So let's check it. Gotta have confidence, though. Negative 4 divided by 11. Control var x. 81 to the x plus 2. 81 raised to the x plus 2. Weird. 27 raised to the 5x plus 4. 5x plus 4. Weird, but same. All right, these are even. We're going to do them down to 2. I know that's crazy, but you have to. So this is, let's see, 2, 4, 8, 16, 32, 64. 2 to the 6 times x minus 2 is equal to, let's see, 2, 4, that's 64. 128, 256, 2 to the 8th. Now, if you don't like doing it with your fingers like that, because that's kind of silly, you can just come over your calculator and just check. What is 2 raised to the 8th? 256. You're done. Boom, done. Now you just set the exponents equal to each other. You get 6x minus 12 equals 16x. 10x equals negative 12, or x equals negative 12 over 10. And of course, it doesn't take long to check it. Negative 12 divided by 10, stow x. Yes, negative 6 over 5 is fine too. 64 raised to the x minus 2. Enter. Weird answer. 256 raised to the 2x. Same weird answer. All right, so this one's a little tricky. Sort of. When does something, I don't care what it is, 2 to something, 3 to something, 4 to something, you know, peanut butter and jelly sandwich to something, equal 1, equal 1, equal 1, equal 1? Well, the exponent has to be a 0. Anytime you raise, I don't care if you raise a peanut butter and jelly sandwich to the 0 exponent, it equals 1. So when would 2 to whatever this is equal 1? Well, this has to equal 0. So 16x squared minus 8x minus 3 equals 0. Haha, tricked you. So all we got to do is factor it. It's not bad. Let's try 4x. 4x. Let's see, 3 and 1. Will that work? 12 and 4. That looks like that's, if I make that negative, that's negative 12, and then positive 4, that would give me 8. So my two answers are x equals negative 1/4 and x equals, we said this was going to be negative, right? X equals 3/4. Not going to check it, it's right. All right, so 2 to the 4x plus 1 is equal to 2 cubed to the x plus a. Which, oh, this was supposed to be multiple choice. I wonder what happened to the multiple choice answer. So we'll let 4x plus 1 equal 3x plus 3a. So if I bring this 3x over, I get x equals 3a minus 1. So if it was multiple choice, that's what the answer would be. That was gross, I'm sorry. So let's see. So let's see. 2 to the y is equal to 2 cubed x. So y is equal to 3x. And over here, oh, these are already equal, so I can say y equals x plus 4. All right, doesn't matter. This is y. I should probably be doing a different color. This is y. So what we're going to do is take this, plug it in. So I get 3x is equal to x plus 4, right? I just replaced the y with whatever it's equal to. So 2x is equal to 4, or x is equal to 2. Well, if x is equal to 2, then y has to be equal to 6. Now let's check that. Is 3 to the 6th equal to 3 to the 6th? Sure. Because I had put a 2 in here and I put a 6 in here. And over here is 2 to the 6th really equal to 8 squared. Well, 8 squared is 64. 2 to the 6 is 64. What are you doing? Crazy dog. All right, let's keep going. This is 3. Oh, you know what? I forgot. My backside of my pen is an eraser. So this is 2 cubed times 2x is equal to 2 squared times 6, or 6x equals 12, or x equals 2. Done. Over here, we've got 3 squared times 3x is equal to 3 to the 3x plus 1. Well, we just set the exponents equal each other. You get 6x equals 3x plus 1. 3x equals 1, or x equals 1/3. Keep going. We're almost halfway done. This is going fast. 3 cubed times x is equal to 3 squared times x plus 2. Set the exponents equal to each other. So you get 3x equals 2x plus 2, or x equals 2. Keep going. 3 cubed times 2x plus 1 is equal to 3 squared times 4x. So 6x plus 3 is equal to 8x. Remember, this is a 4. So 3 is equal to 2x, or x is equal to 3 over 2. So this one just quickly changed the base, so b to the y is equal to x. Done. You just switch. All about the base, and then these two switch. Right in logarithmic form, well, it's all about the base, right? Log base 2, and these two switch, of y is equal to x. Done. Wow, that was easy. What are the domain and range? So in this case, the domain for this one is x has to be greater than or equal to 4. Excuse me. X has to be greater than 4. It can't be equal to 4 because then it would equal 0, and that would be undefined. And then if you remember, all log functions just go like this. So the domain, so in this case, let me erase. The domain is x greater than 4. The range is all reals, or negative infinity to positive infinity. And on this one, I should have put 4 to positive infinity. Something like that. Okay, moving on. Sorry about the cold, kids. Surviving, though. Domain and range. So in this case, x can't be 8, and it can't be anything bigger than 8. So the domain in this case is negative infinity all the way up to, but not including 8. And it's a log function, so the range is all reals, or negative infinity to positive infinity. Moving on up. Ooh. This one's tough. Tough. So log of 5 is equal to a. So I want to try to write this thing. Oh, man. So here's how it's going to work. This is the same as, here's how it's kind of tricky. This is the same as log of 10 times 25. Now I do that because I know what the log of 10 is. So this is the same as the log of 10 plus the log of 25. Now the log of 10 is just 1. So there's your answer. Now, why is this one 2a? Well, this is the same as the log of 5 squared, but I don't like the 2 there. I like it 2 there. And isn't this a? That's why it's that one. Tough question. But log b of 36. Oh. So let's set that equal to x. So I could do b to the x is equal to 36. No, I don't want to do that. I don't know if that helps. So I can make this 6 squared and put the 2 out front. Put the 2 out front. 2 goes out front. So that works. So that checks. This is subtraction. That would go back to division. So that would be log base b of 72 over 2, which is 36. That works. And this is going to go back to multiplication, so this would be log base b of 9 times 4, which is 36. So that works. It's this one that doesn't work. So that's the wrong answer. That's the right answer, because it's the wrong answer. Okay, so what I'm going to do, I'm going to rewrite this. So this is the log of a to the 1/2, a to the 1/2 minus log of b cubed, but the cubed goes back here. Oh wait, the 1/2 goes out front. So log of a is 2, and the log of b is 3. So what this thing turns out to be is 1/2 times 2 minus 3 times 3. 1/2 of 2 is 1, minus 9 is negative 8. Tough question. So let's just rewrite this. All they're asking for, it's a tricky way to ask you just to rewrite it. So log of x squared, but the 2 goes out front, plus the log of y minus the log of z to the 1/2, but we'll put the 1/2 out front. Sorry, kids. Excuse me. I should cover the mic, huh? So this is 2a plus b minus 1/2 c. Condense this. So the first thing I'm going to do is return the 1/2. So that's the square root. And then this turns it, and I return the 3. And so this turns into division. So what I end up with is the log of the square root of m over n cubed. So if I take this and I solve this for x, you change the base, you do 5 squared equals x, right? 5, it's all about the base, and these two switch. So x is equal to 25. Okay, so what is the square root of x? 5. There's your answer. Ka-ching. Page 5. Don't worry, the problems get harder. How long are we in? 32 minutes, and we're only on page 5. We only got 9 more questions to go. Yeah, 9 more pages to go, whatever. So, change the base. 2 cubed equals x plus 1. This is 8. So, subtract 1, I get x equals 7. 8 to the 2/3 equals x plus 1. Well, if you put 8 to the 2/3 in your calculator, what you'll find out is that's 4 is equal to x plus 1, so x is equal to 3. X to the negative 2 equals 9. Ooh, that's tough. Well, this is really 1 over x squared equals 9 over 1. Now, if I multiply both sides by the common denominator, which is, in this case, x squared, I get 9x squared equals 1, or x squared equals 1/9, or x equals plus or minus 1, the square root. You're going to take the square root, square root of 1/9. But you can't have a negative number, so the answer is x equals, and the square root of 1/9 is 1/3. I want to know what k equals. So log k is equal to log of, let's see, return this, c. So v to the c times p. Well, you got log equal to log, so k is equal to v to the c times p. All right, so this is subtraction. It goes to division, so we get log base b of 36 over 2 equals log base b of x. Since I have log base b of that and log base b of that, those two things in yellow must be equal to each other, so 18 is equal to x. 36 divided by 2 is 18. All right, kids, we're on problem, I don't even know now. Oh, 50. Oh, wait, did I finish this page? I don't think I finished this page. Did I finish this page? Nope. At least one more over here. Oh, one more. All right. So this is subtraction. It goes to division. So we get log base 4 of x squared plus 3x over x plus 5 equals 1. Okay. So 4 to the 1 has to equal x squared plus 3x over x plus 5. Change the base. This is just 4. So cross multiply. So I get x squared plus 3x equals 4x plus 20. Remember, we're going to cross multiply. Or just multiply both sides by x plus 5. So I get x squared plus minus x minus 20 equals 0. X minus 5. X plus 4 gives me two solutions. I get my solutions of x equals 5 and x equals negative 4. Don't forget, all logs must be checked. And I think they both work. So those both work. Which is an expression for the equation in figure B? Well, it's a log, so it can't be these two. And it is the inverse of 2 to the x. So log base 2 of x. Well, I'm not even going to try to attempt to graph that. It looks like this. I don't know why I did that. So let's just skip that question. I might just throw that one out. Kind of dumb. Which graph represents the log base 2 of y? Let's see. All logs go through the point 0, 1, so that's not going to be it. And that is a reflection of a log. And that is a reflection of a log. So there it is right there. Which graph represents the inverse of this? Well, this is an exponential, so I should be looking for a logarithmic. That's not logarithmic. That's not logarithmic. That's not logarithmic. There's the answer. All right, the graph of log 3 to the x would be go through here, and it would look like this. The log of base 3 to the x would go through the point 1, 0, and it would look like this. It also goes to the point 9, 1. This one also goes to the point 1, 9. But you can use your calculator to graph those. Oh, that was a fast page. I was thinking about this one. It's going to get a fast page. So y equals log. Sketch and label the graph. All right. So it goes through point 1, 0. Excuse me. It goes to the point 1, 0 or 0, 1. No, 1, 0, and it also goes to the point 10, 1. So it's log base 10. It's gonna look. Oh, see, that's why I don't do this very often because I can't graph on this thing. Let's try to do a better job. There we go. And then it comes down like this. Okay. On the interval from point, yeah, whatever. Well, point 1 would be right here, actually. So I probably should just stop right here. So there again, I made another dumb mistake. It said on the interval from 0 to, see, notice, see, that's, I guess what I'm testing is the fact that you understand, first of all, it's going to stop here. And it's going to stop here, and I'm only graphing to here. I'm not going past that. So here's the equation of the line y equals x. If I wanted to graph that reflection, it would look like this. Oops, no arrows. So, kind of forgot what I was doing on that one. I just wanted to test that one. All right, so graph 4 to the x. So it's all going to go through, it's an exponential. It's going to go through 1, 0. And when x is 1, you get 4. When x is 2, you get 16. When x is negative 1, you get 1/4. So it's going to be this. And it goes through this point. And it goes through 4, 1. And it looks like this. There's the inverse. 62. Let's go to 63. 63 says, which graph represents the inverse of an exponential? That is an exponential. That looks good. This is not an inverse of an exponential. And this is not the inverse of an exponential. So this has to be the answer. Okay, so what we're going to do is just expand this. So we get log of a to the 1/2 minus log of b cubed. Okay, that doesn't go there, that goes here. And that doesn't go there, that goes here. So it's really 1/2 of log a. Oh, I already did this problem. It's the second time I've had a problem. Oh, there's this one. Oh, wait, no. Yeah, this one actually has the multiple choice here. -8. Maybe that's why I screwed up. 8. So, I want to convert this thing so it only uses 2s and 3s. So let's do this. Log base b of 12 to the 1/2 power. So that's equal to 1/2 log base b of 4 times 3, which is equal to 1/2 log of 2 squared plus log of 3. Now you have to remember, why did I choose 2 squared? Because I wanted it to look like 2's. So this 2 comes out front. So I get 1/2 times 2 times log of 2, which is 0.6931, plus the log of 3, which is 1.0986. Head's probably in the way for that one. So 0.5 parentheses 2 parentheses 0.6931, 0.6931 parentheses plus 1.0986. Enter. 1.2424. 1.2424. Wow, that was crazy difficult. So, didn't give you a lot of room here. So I'm going to write this as 5 squared. So this thing becomes log of 5 squared, but the 2 comes out here. And I'm going to write this one as 3 squared. So minus log of 3 squared, but the 2 comes out here. So this becomes 2 log a, by the way. Log a of 5 is 2.32 minus 2 times log of 3, which is 3.17. So 2 times 2.32, 2 times 2.32 plus 2 times 3.2 times 3.17. 10.98. All right, now how am I going to do 45? Well, this is the same as log of a of 45 to the 1/2. So that's the same as 1/2 times the log of 5 times 9, which is the same as 1/2 times the log of 5 plus 2 log 3. Now, why 2 log 3? Well, this should be 3 squared, but we'll bring the 2 out front. So this is 1/2 times log of 5 is, so I'm going to do 0.5 parentheses 2.32 2.32 plus 2 times 3.17 4.33. So the answer is 4.33. All right, that one's done. That was a tough one. Sorry, kids. Excuse me. Oops. Need more space. Okay, now we're doing the word problems. Oh, hold on. Is there more up here? There's one more up here. Oh, gosh. So this is going to be 2 log b of r plus log of s. So this is equal to 2 times 0.75 plus 0.25, and that's 1.75. I can do that one in my head. And then this one's going to be 1/3 log, remember this is 1/3 exponent, so that goes out front, log of r minus log of r plus log of s. So this is 1/3 of 0.75 minus 0.75 plus 0.25. So this is 0.25 minus 1, which is equal to negative 0.75. There's your answer, I hope. Appreciate your car. If the car's cost when new is $15,000. Oh, it's been a long video. And the rated appreciation is 30%. The value of the car is now $3,000. How old is the car to the nearest tenth of a year? So the new value of the car is $3,000. The original value was $15,000. And we're going to do that 1 minus 0.3 to the t. So the first thing I do is divide by 15,000. And cast out the zeros. So I get 1/5. So I get if you do it on your calculator, you get 0.2 equals 0.7 to the t. Because 1 minus 0.3 is... So now it's all about the base. So log of 0.7 of 0.2 is equal to t. So that's what I got to do in my calculator. Control log 0.7 0.2. 4.512. So 4.512 equals t, round to the nearest tenth of a year, 4.5 years. All right. The amount A in milligrams, 10 milligrams of dose given by the formula of that. Find the nearest tenth of an hour. How long will it take for half of the dose to be in the body? So half. If we started out with 10, I want to know what half is. That's 5. So 5 is equal to 10 times 0.8 to the t. Or 0.5 is equal to 0.8 to the t. So control log. Oh, I haven't converted it yet. So log of 0.8, it's all about the base, of 0.5 equals t. 0.8, 0.5, boom. 3.106. So t equals 3.106. So time equals 3.1 hours. It's got a half-life of 6,000 years. After T years, 1/5 of the original sample remains radioactive. Find the radioactive equation decay if P equals that, where P is the part of the substance with the half-life H remaining radioactive after a period of time, T. A given substance has a half-life, H, of 6,000 after T years. 1/5. So I have 0.2, which is 1/5 of this thing is left, of 0.5 to the T over 6,000. So when I convert this to a log question, I get log of base 5 of 0.2 is equal to T over 6,000. Not 60,000, 6,000. Well, let me figure out what this is. Log of 0.5 of 0.2 equals. So I end up with that number. So what's that? 2.322. Let's say 2.32 is equal to T over 6,000. Well, to get rid of that, I just multiply by 6,000. So that's what I got to do. Multiply by 6,000 times 6,000. Not 60,000, 6,000. And that's what I started with. And they want us to round to the nearest 1,000 years. So 13,931. 13,931. I want to round to the nearest 1,000 years. So that's 14,000 years. All right, there it is. An archaeologist can determine the amount. Measure around it carbon-14, a radioactive substance contains in the specimen. The formula used to determine the age of the specimen is that. Ooh, that looks complicated. Where A is the amount of carbon that the specimen contains. A0 is the original amount. Okay, so whatever. T is the time in years. 57,60 is the half-life of carbon-14. That's why it's 5760. A specimen that originally contains 120 grams, so now contains 100. So it now contains 100. It used to contain 120, and then we just fill in the rest of the formula, times 2 raised to the negative T over 5760. Get the weird thing alone by dividing by 120. So you get, what is that, 5, 6. So 5 over 6 is equal to 2 to the negative T over 5760. It's all about the base, so log base 2, these two things switch, of 5 over 6 is equal to negative T over 5760. So I got to do log base 2 of 5, 6. That's going to be negative. Control log base 2 of 5 divided by 6 equals that thing. So negative 0.26, just to have a number, negative 0.26, repeating, is equal to negative T over 5760. So I'm going to multiply by 5760, but I'm going to multiply by negative 5760 because these will cancel and it'll make positive T. So we're going to multiply by negative 5760. So times negative 5760 equals 1515. So 1515.078. So nearest 100 years, 100 years would be this one, so it's 1,500 years. All right, page 9. The current population of Little Pond, New York is 20,000. The population is decreasing, represented by the formula of that, where P is the final population, T in time, and A is the initial population. What will the population be? So we don't know what P is. In 3 years from now. Well, the current population is 20,000. So we're going to start with 20,000. And 1.3 to the negative 0.234 times how many years? 3 years. So we just type that in our calculator, 20,000 times 1.3 raised to the negative 0.234 times 3. 234 equals 1663. So P equals 1663.572. And round your answer to the nearest 100 people. So P equals 1,700 people. Determine nearest tenth of a year. How many years it will take for the population to reduce half of its presence? So we want to, half of its presence would be 10,000. So we want to know when it's going to be at 10,000 people. 1.3 to the negative 0.234 T. So if I divide by 2, I get a half. So 0.5 is equal to 1.3 to the negative 0.234 T. That's a 4. Now it's all about the base, so we'll do the log. So log base 1.3 of 0.5 is equal to negative 0.234 times T. So come over to my calculator, control log 1.3 1.3 of 0.5, enter, and then I'm going to divide by negative 0.234. So divided by negative 0.234, and I get T equals 11.29 years. T equals 11.29 years. Nearest tenth of a year, so T equals 11.3 years. So I want to know when this equals 32. So 32 is equal to 2 to the T over 3. So it's all about the base. So log base 2 of 32 equals T over 3. So control log, this will be 5, but just so you show, of 32 is equal to 5. So 5 is equal to T over 3, so T equals 15. G is the final number of bacteria. A is the initial number of bacteria. Approximately how many hours will four bacteria first increase to 2,500? So 2,500 is going to be the end result. Our initial amount is 4, and it's 2.7 raised to the I think this should have a T up here. 0.584 T. I believe so. Divide by 4, 1,200. What's that, 625? 625 is equal to 2.7 to the 0.584 T. Log of base 2.7 of 625 is equal to 0.584 T. So control log 2.7 1.7 of 625 equals that. Divide by 0.584, and I get 11.09. So T equals 11.09 hours, I guess, to the nearest hour, so it'll be 11 hours. Starting point of 100 bacteria, that's the starting point. Use to find the bacteria after time period. If each time period is measured in 15 minutes, so we just got to figure out times periods. Well, for the population to reach 50, so 51200 is equal to 100 times 2 to the t. So if I divide by 100, I get 512 is equal to 2 to the t. So log base 2 of 512 is equal to t. So t is equal to, let's see, 2, 4, 8, 16, 32, 64, 128, 256, 512. T equals 9. Now that's 9 time units. It says how long will it take? How many minutes? You got to take 9 times 15. So 15 times 9 is 135 minutes. The number of hours in Central Village, New York grows every hour according to that function, where H represents the number of hours and T represents the number of hours since January 1995. A Cinderella engineering firm has suggested larger well exceeds 1,000. So I want to know when it'll exceed 1,000. I need to know when it's going to exceed 1,000 houses. So 1,000 is equal to 540. 1.039 to the t. Well, if I divide by 40, I don't know, it doesn't matter what this is. So now what I have is an exponential, so it's going to be the log of, it's all about the base, 1.039 of 1,000 over 540 is equal to t. So control log 1.03. I don't know how that does that. 1.039 of 1,000 divided by 540. 16.105. So T equals 16.105. So it's about 16 years. It's going to be in the 16th year. So let's see. During which year will this happen? So it's 1995. So if you take 1995 and you add 16 years, I'm going for an hour and 3 minutes. So we're going to add 1995. You get 2011. So it'll happen during 2011. Oh my gosh. Thought I was done with these. So let's see what we got here, kids. In this equation, represents the number of snowboarders in millions. X represents the number of years since 1998. Find the number of years snowboarders will be 10 million for the first time. So Y represents the number of snowboarders in millions. So we're just going to use 10 is equal to 0.5, 1.21 to the X. Divide by 0.5, I get 20 is equal to 1.21 to the X. Log of 1.21 of 20 is equal to X. So that's all we need to do. Control log 1.21 of 20. 15.7. So X equals 15.7. In which, find the year in which. So you take 1988, and you add 15.7. So we'll add 1988. And we get 2003. So during 2003 it will happen. It's 2003.7, but it's during 2003 it will happen. Since 1980, the population of the city of Brownville has grown according to this mathematical model, where X is the number of years since 1980. Explain what the number this and this represent in this model. So 720,500 is the population in 1990. So 720,500 is the population in 1980. And the 0.022 represents 0.22% increase. Now, the reason it's an increase is because it's bigger than 1. So when, and you also see it's going to increase. When will it reach 1,548,800 is equal to 720,500, 1.022 to the x. So we're just going to divide. I'm not sure. That looks like it's double. No, it's not quite double. So 1,548, 800 divided by 720,500 equals a little over 2, whatever. So you get that, 1408 over 655. You can get that as a decimal, but it doesn't matter. 1.022 to the x. It's all about the base. So log of 1.022 of that fraction is equal to x. So I'm going to do control log of 1.022 of that fraction, the answer, is equal to x. Notice I put the answer in there for me. That's nice. So x is equal to 34.85. So x is equal to 34.85. And that's since 1980. So if I add 1980, it will happen during the year 2014. During which year? So during which year? It'll happen during 2014. An oven is turned on. Temperature T is represented by that, where M represents the number of minutes, T represented. How many minutes does it take for the oven's temperature to reach 300 degrees Fahrenheit? So 300 is equal to 400 minus 350 times 3.2 to the negative 0.1 m. So subtract, I get negative 100 is equal to negative 350, 3.2 to the negative 0.1 m. Divide by negative 350. Divide by negative 350. So that's positive. So 10 over 35 is equal to 3.2 to the negative 0.1 m. It's all about the base. So log of 3.2 of 10 over 35 is equal to negative 0.1 m. So control log 3.2 of 10 divided by 35 equals, and then that we're going to divide by negative 0.1, and we get 10.77. So M equals 10.77. Round your answer to the nearest minute. Minutes is 11 minutes. 2 more of these, and I think we do regression. Drew's parents invested $1,500 in an account such that the value of the investment doubles every 7 years. The value of the investment, blah, blah, blah. How many years to the nearest tenth of a year will it take for the value of the investment to reach $1 million? So 1 million is equal to 1,500 times 2 to the t over 7. So we're going to divide by 1,500. So 1 million, 1, 2, 3, 4, 5, is that 1 million? That's 3. That's 10 million. Whoa. Oh, I know why it's doing that. 1, 2, 3. 1, 2, 3, divided by 1,500 equals that. So 20,000 over 3, wasn't that what it was? Is equal to 2 to the t7. So log base 2 of 20,000 over 3 equals t over 7. So we're going to do control log base 2 of the answer equals that. And then to that, we're going to times that by 7. So 88.9 years. So t equals 88.91 years. 91 years, nearest tenth of a year. 88.9 years. 88.9 years. Kristen invests her bank. So how long must she leave the money in the bank to double? So she's going to have $5,000. So we want to end up with $10,000. She started with $5,000. 1 plus 0.06 over, now we're compounding it monthly, so that's 12. 12 times 12t, compounding it monthly. Oh, n equals 12. Okay, so this is 2 equals 1. I don't know what this is. Let me figure out what that is. 1 plus 0.06 divided by 12. 1.005. 1.005 to the 12t. It's all about the base. Log of 1.005 of 2 is equal to 12t. So log, control log of 1.005 of 2 equals that. And then we're going to divide that by 12. So 115.55. T equals 115.55. That's a lot of hours. Oh. Just knocked my lighting out, chillin'. And I'll mess things up a little bit. All right, hopefully we're on the regression. Oh my gosh. Well, this isn't a page. That's good. We'll delete that. One less page. 2 pages of regression. All right, jeez. So how many years will she have? 2,500. So we're going to go with 2,500. All right, we're doing these fast, kids. 1,000 times 1 plus 0.028 over n, compounded monthly, so n equals 12 to the 12t. So this is over 1,000. So I've got, that's 2.5. So 2.5 equals, I don't know what this is, 1 plus 0.028 divided by 12. That. So 1.023 repeating, 1.023 repeating to the 12t. So log of 1.023 repeating of 2.5 is equal to 12t. So control log using the answer of 2.5. Enter. And we're going to divide that by 12, divided by 12, and we get 32.76. So t equals 32. Excuse me. 76. So t equals 32.8 years. Takes a long time for money to double. Sean invests $10,000 at a rate of 5% in continually. Bah. I don't know why we tell me this. We just use E. Determine to the nearest dollar the amount he will have after 2 years. So A equals, it's easy, 10,000. E, now my rate is 5%, so 0.05 times, after 2 years, times 2. So 10,000, 1, 2, 3, that's my doggy making friends, times E to 0.05 times 2. What's 0.05 times 2, right? $11,051. So A equals $11,051.71. That's how much money you have. Round of money. How many years would it take the initial investment to double? So we want $20,000 is equal to $10,000. E to the 0.05 times T. So we're going to divide, so I get 2 equals E to the 0.05 T. So it's all about the base, but in this case we're going to use natural log of E, we don't need to put that, of 2 is equal to 0.05 T. So we do the natural log of 2. And we divide, enter, and then we divide by 0.05. 13.86 years. So 13.8629. What do we round it there? Nearest year. So it'll take them 14 years. There's money to double. That's pretty good, actually. The relationship between the relative size of an earthquake S and the measure of the earthquake in the Richter scale R is given by that. If an earthquake measures 3.2 on the Richter scale, what is its relative size to the nearest hundredth? So log of S is equal to 3.2. Put a 10 here, so 10 to the 3.2 is equal to S. So 10 raised to the 3.2 equals 1584. S equals 1584.89. To the nearest hundredth, 8931. So S is equal to 1584.89. That's it. Let's skip this question. I don't even want to look at it anymore. So we're going to do an exponential regression. So let's get our calculator ready for that. We're almost done, kids. How long have we been going here? Hour and 18 minutes. So we'll call it X. Well, let's just do it. Stop. X and Y. And we're going for 6 weeks. So 0, 1, 2, 3, 4, 5, 6. 100, 88.3, 75.9, 69.4, 59.1, 51.8, 45.5. Then we're going to do exponential regression. So we come over here, we go menu, stats, stat calculations, and exponential regression. We choose X, we choose Y, and we click OK. So my equation is y equals a times b to the x. So y equals a times b to the x, where a is equal to 100.326, 100.326, 250, and b is equal to .876, 865. 865, or round to the nearest tenth. So my equation, y equals, wasn't that 100? Oops, that should have been a 100. 100.3.9 to the x. So the question says, determine the half-life of the radioactive material found to the nearest tenth. So really what that is we want to know when this is going to be equal to 50. So 50 is equal to 0.9 to the x. So log of 0.9 of 50 is equal to x. So log 0.9, ooh, probably should go back to my calculator. Log 0.9 of 50. Oops. Let me erase that because that doesn't make any sense. The half-life should be somewhere. Where the heck did I go? Oh, 0.5 is equal to 0.9x. I think I used 2. So let's go back here. No, yes, use 50. So I want to know when this is equal to 50. So I divide by 100. So control log of 0.9 of half-life is 0.5 equals 6.57. Nearest tenth, 6.6 years. 6.6 years. And that's somewhere around here, I guess. It's a little off. How much radioactive material left after 50 weeks? Oh, this is not years, it's weeks. So I don't know after 50 weeks. So I do y equals 100.3.9 to the 50. So 100.3 parenthesis 0.9 raised to the 50. 0.516. 0.516, so 0.5 will be left. Oh, yeah, well, that was down here. Sorry. All right, 2. Next problem. Let's get rid of this. Don't save. Back into this. X, Y, 760, 740, 760, 740, 725, 700, 650, 630, 600, 580, and 550. Zero 0.184, 0.328, 0.565, 0.565, 1.079, 1.079, 1.291, 1.634, 1.862, 1.862, and 2.235, 2.235. And are we doing exponential again? Oh, we're doing logarithmic. So, well, I don't know if I've ever done a log. I've done a log in a long time. Logarithmic. X and Y. I don't know why it's got natural log. I shouldn't have. Did I use natural log? It just should be log. Click on the wrong one. It's been a while since I did these. Damn it. Doggone it. Nope. So, actually, this is not one I want you to do. They never asked logarithmic. Let's just go back. Do these last two problems, we'll be done. They never asked logarithmic on a test. I don't know why I even bothered to put that one on there. I meant to get rid of that one, I guess. We'll make sure this one's not too. No, this is logarithmic too. I don't want to do that one. I'll leave those as bonus. Exponential. Okay, so we're going to do this one, this last one. Last problem, thank goodness. So X and Y, my doggy's getting restless, 80, 85, 90, 95, and 100, 0.891, 1.07. 1.302, 1.5, and 1.893, 1.893. Menu, stats, stat calculations. We're doing exponential regression. We call it X. We call it Y. I'm just going to give you the answer this time so we can do this quickly. Oops. So there's A. My throat's about to give out. We're going to round to the nearest thousand. So P equals 0.047, 0.047. B, which is 1.3, no, it's not, 1.036 to the T. So the question says, what's the population skipyard in 2020? Well, I gotta be careful here. Let's see. 1980 represents 1980, and 100 represents 2000, and I want 2020, so that would be 120. So that's 120. So that's what I want to use for my T. So I come over to my calculator and I go, okay, 0.047 parenthesis 1.306, 1.036 raised to the 120 exponent, and 3.275. 3.275, around there's 1,000, 43. So 3.275. And kids, finally, that one is over. Hour and a half later. I hope you all enjoyed it. I sure did.